Hello everyone, in this video we're going to learn on molar solution. So first learning objective is to define molarity, what concentration means, formulae and units used in this topic, and lastly calculate the number of moles or grams of solute from solution, concentration and volume. This learning objective is in your learner's guide, the one I have printed for you with the checkbox. Okay, so next page. So here we are defining what is molar solution. So another word for it is molarity. It is the measure of concentration of a substance, which is chemical species, which has dissolved in a solution. So in other words, it is the number of moles of the substance in 1 liter of solution. So the units used for this topic is mole per liter or mole per dm cube or big capital letter M, but Cambridge O-level usually use mole per dm cube. Your syllabus usually use this. Okay, let me highlight for you. Although your notes have this capital letter M, but this capital letter M and mole per liter is usually in A level. Okay, usually in A level, I would say. So your syllabus just focus on this mole per dm cube here. Here we have a series of concentrations from very diluted to very concentrated. Alright, just imagine you are making a series of concentration of Ribena juice. So the very diluted is not very sweet. The concentrated one is super sweet. Okay, with the same volume, just you can see right, they are in the same volume of the same size of glass. So here's the description. The higher the concentration, the more amount of substance dissolved in that particular volume of solution. Okay, next page. So things to remember in this topic: 1 dm cube is equal to 1000 centimeter cube or 1000 milliliter. Concentration for this topic can be in gram per dm cube or mole per dm cube. These two are the units of concentration. Okay, I forgot to write this. Units. But the word molarity only can be used for mole per dm cube or big capital letter M, because it means number of moles in 1 liter or 1000 or 1 dm cube. So here I break down to two things: gram per dm cube or mole per dm cube or big capital letter M. These two only means for molarity. Okay, the word mole must have the mole in front. Okay, next, the formula used in this topic. Alright, formula used in this topic. My favorite way to remember this topic is if volume provided in dm cube, number of moles is equal to concentration times volume. So the letter I like to use is N equal to C times V. So your concentration must be mole per dm cube and your volume must be in dm cube. Okay, because why? If I work out the formula here, alright, in your notes, this PDF, I've written here number of moles equal to mole per dm cube, which is the concentration, times dm cube, which is the volume. So if I were to cancel out, so the dm cube and dm cube will cancel each other, top and bottom will cancel, so leaving your number of moles. So the unit is moles, right? So here you go. Okay, so the units have to make sense when you put in those values. So if volume provided is in centimeter cube, same thing also, number of moles is equal to concentration in mole per dm cube times volume. If it's in centimeter cube, you have to divide with 1000. Alright, that's the important thing. Let me highlight it here. Your unit for concentration must be in mole per dm cube, and if it's in centimeter cube, you need to divide with 1000. So here I already put the warning here. Okay, so you can change the subject whenever you need to. For example, if you want your concentration to be the subject, so just remember number of moles is equal to concentration times volume. So if you want to make your concentration as the subject, you need to move this volume to other side, right? So the other side becomes divide. So therefore your concentration is equal to number of moles divided with volume. So here's the formula. Make sure you know that your concentration at this case is mole per dm cube is equal to number of moles divided with volume. This case the volume is dm cube, yeah. Alright, let's say your volume available is in centimeter cube. So don't forget your volume, if in centimeter cube, you must divide with 1000, yeah, as usual. Divide it with 1000. Okay, divide with 1000 if it's in centimeter cube. Okay, centimeter cube. If it's in dm cube, no need to do anything with it, just put in the values. So another case, what if you want the volume? So if you want the volume as the subject, so let's recall our formula. Number of moles is equal to concentration times volume. So just move your concentration to the left hand side, it will become divide, right? So volume stays on the right hand side, number of moles still stays on the top, divide with concentration. This concentration has to be mole per dm cube. Another formula you need to know is concentration, the unit is gram per dm cube, is equal to concentration in mole per dm cube times mr. Mr is your relative molecular mass. Otherwise, your concentration in gram per dm cube is also known as mass divided with volume, dm cube. Notice the unit used here, gram, has been divided with dm cube, which is you got here gram per dm cube. Alright, or this volume in dm cube, if you were given in centimeter cube, your centimeter cube must be divided with 1000. Make sure when you key in your calculator, after dividing, you must put a bracket here to make your life easier. Or otherwise, if you don't put any bracket, your mass here in gram divide with volume in centimeter cube multiply with 1000, just like this. Okay, if you want to use the divide, make sure you put the bracket here. So I have explained the formulas that's displayed in your notes. You may change the subject whenever you need to find another quantity. You may change the subject if you need to find the other quantity. Here, let's try our exercise 10.11 on your page 15. So first question, how many moles are there in each of the following solutions? So I've highlighted here your moles is N. Here part A, 1000 centimeter cube, this is volume. Your 0.5 big capital letter M, this is your concentration, yeah. This is another word for 0.5 mole per dm cube. Okay, So how do we find the number of moles? Number of moles equal to question mark, question mark. And so the formula is number of moles equal to your concentration must be in mole per dm cube times volume. Since your volume given is in centimeter cube, so your centimeter cube must be divided with 1000. Okay, must remember this. So what you can do now is to substitute the value. So number of moles, I just gonna put the letter N is equal to concentration. Concentration is 0.5 mole per dm cube. You can omit the units if you are confident already, but this is how I'm going to show you. The units will be cancelled by the end of the day. 1000 divided with 1000. This is in centimeter cube on the top. Since the bottom here is actually centimeter cube per dm cube, which literally means I've written in your notes this one is actually there is 1000 cm cube in 1 dm cube. Okay, literally it means like this. So what you can do is now you can cancel the units. This one cancel with this one. Actually this dm cube will be cancelled with this one if you work out your fractions and division. You can cancel this 1000 and 1000 here, the top and bottom, leaving this 0.5 mole. So therefore your answer will be number of moles is equal to 0.5 moles. Okay, what if you're given with this 5 dm cube of 2 molar nitric acid? So let's highlight what is given here. This is the volume, this is the concentration. So let me label, this is your volume, this is your concentration, letter C. This one is mole per dm cube, yeah. So the famous formula we're going to use is number of moles is equal to concentration in mole per dm cube times volume. Since you are given with dm cube, so just use dm cube without the 1000. Okay, so now you are substituting the value. Number of moles is equal to concentration is 2 mole per dm cube times volume is 5 dm cube. So now, alright, you can see the units can be cancelled, dm and dm cube can be cancelled, leaving your final answer will be 10 moles. Alright, so let me say this out. You can omit the units when you write out the working, but make sure you know which multiply with which. Let me write it here. I have said you may omit the units in the working, yeah, in the working, but make sure you know which one to use. Okay, don't just blindly use whatever values you have. You just multiply or divide or times, or these units I have written here is to prove how do you get these moles by the end of your answer. Okay, next question 2. What is the molarity or concentration of each of the following solutions in mole per dm cube? Okay, let's highlight the things that is given here. Molarity, you must have been dm cube, so 1000 centimeter cube and 2 moles. So let's label here. This is your volume, this is your number of moles. Your concentration is unknown, so I'm gonna put here question mark. So your famous formula is number of moles is equal to concentration times volume, which is this case in centimeter cube. You need to divide with 1000. Alright, so how do you move this? Your volume will be moved to the other side, becomes division, so leaving your concentration on the right hand side. Concentration is equal to number of moles divide with volume, centimeter cube, divide with 1000. Make sure you put this bracket when you use the calculator. Okay, so let's substitute the value. Concentration, number of moles is 2 moles. Concentration is equal to 2 moles divide with 1000, divide with 1000. Okay, so the 1000 I've substituted here. Okay, please don't confuse. This one is the same as this one. So your moles is in blue, so here. So after that you calculate the value. 1000 divided 1000 is equal to 1. So 2 divided with 1 equal to 2. So the units for this concentration is mole per dm cube. Bear in mind this is moles. This is actually has converted to dm cube, to be honest, so that's why moles per dm cube. Here you go. So here our question 2c, 2 dm cube of nitric acid containing 4 moles. So from question 2 we are required to find concentration. So this is question mark. 2 dm cube is volume, 4 moles is N. So writing our famous equation formula is number of moles is equal to concentration must be in mole per dm cube times volume. Your volume is in dm cube, so no need to divide with 1000. So we want our concentration, so we need to move this volume to the other side, so it will become divide. So concentration is equal to number of moles divide with volume in dm cube. So you get your concentration. Number of moles is 4 moles. So divide with 2 dm cube. So let's divide 4 divide with 2, you get 2. So lastly your units is mole per dm cube, so you get 2. That's how you get the answer. Alright, so on question 2f here you are given mass in 4 dm cube. This is volume, so you are required to find concentration. So how are we going to do that? Because we know our formula is your number of moles is equal to concentration times volume, but how do we get the number of moles? But how do we get the concentration if we don't have the number of moles, right? You are required to find this. Your volume is available, but where is your concentration? Where is your number of moles? But you are given mass. So what you can do is your mass is converted to dm cube. What you can do is that your mass should be converted to number of moles. Do you remember this triangle? If yes, okay, so you are required to find the number of moles. So number of moles is equal to mass divided with mR. So let's write here, number of moles is equal to mass over mR. Your mass given in this question is 3.65 gram of HCl divided with the mR. mR for HCl, hydrogen is 1, chlorine is 35.5, you get 36.5. So 36.5. Remember, right? This is gram per mole. So you cancel. So when you key in your calculator, you should get 0.1 mole of HCl. So now you get your number of moles already. So what you need to do is to put it here. Okay, you know already your concentration. Concentration is equal to number of moles divided with volume in dm cube. Don't forget your volume, you move to other side, become divide, yeah, so that you get here. So now substitute the value. Your number of moles is 0.1 mole. Your volume here is 4 dm cube. Now key in your calculator, you should get 0.4 mole per dm cube. Okay, so just a reminder, if you have mass, do not forget to use this triangle, yeah. Then you convert to number of moles. After you getting number of moles, you can substitute to your famous formula here, making the concentration of the subject, and here you go. This is the final answer. Let's proceed to question 3. Calculate the mass of NaCl needed to make 200 cm³ of 0.5 molar, which is this one is mole per dm cube solution. So let me highlight here. Let me remind you, this is mole per dm cube. I already highlighted the things that is needed. Mass is small m. Question mark, you have no idea what's the value for this one. Volume is the 200 cm³. This one 0.5 molar. This is your concentration. So how do you find the mass? Since volume and concentration is provided, so you can use the famous formula, number of moles is equal to concentration mole per dm cube times volume in dm cube, because in centimeter cube, because the given volume here is in centimeter cube. So when you're given with centimeter cube, you must divide with 1000. Okay, so let's substitute the values here. Number of moles is equal to concentration, which is 0.5 times volume. Volume you have 200 cm³, must be divided with 1000. Then you key in your values in the calculator. You should get 0.1 moles how do you convert the moles to mass? So remember the triangle. So you want to find mass. So mass is equal number of moles times mR. So let's use the formula. Mass is equal to number of moles times mR. Number of moles you have found out from the previous working is 0.1 times mR for NaCl. Use your predict table to calculate the mass. Sodium is 23, chlorine is 35.5, so you should get 58.5 here. So 58.5 shall be substituted here. So final answer, you should get 5.85 gram. Next question, 3C. What is the mass of NaCl needed to make 2.5 dm cube of 0.04 molar solution? So this M again, this is concentration in mole per dm cube. This volume, you are required to find mass. So use the famous formula. You have volume and concentration. Number of moles is equal to concentration times volume. This one already in dm cube, so no need to divide 1000, yeah. So the number of moles is equal to concentration 0.04 times volume is 2.5. You should get 0.1 moles. These moles you need to convert to mass. By using the triangle. Alright, please remember, yeah, from time to time you may need to use this. So mass is equal to number of moles times mR. Okay, so mass is equal to number of moles times mR. Number of moles you have found out earlier is 0.1 times mR of sodium chloride is 58.5. So 58.5 here. So you multiply, key into your calculator, you should get 5.85 gram. Okay, so here's our final answer. So before we end this, let's go to the steps to success. So first step, label the given values and find the unknown. For example, I will label concentration as C, number of moles as N, volume is V, mass is M, relative molecular mass is mR. Okay, pardon me. Next step, you must remember the formulae. These are the formulae you need to remember by heart. Okay, I don't need to explain all this. You can just read again in the notes. Please remember, please remember, please remember. And I put a star here. You can change the subject of the formula whenever you need that quantity. Such as, you already have number of moles, I label it as N, concentration as C, but the volume is question mark, but in dm cube, volume as question mark, concentration make sure is mole per dm cube. So you change the subject, you write the famous formula, number of moles is equal to concentration times volume. Since you want the volume, you move the concentration to the other side, leaving the volume alone. So you get volume is equal to number of moles divided with concentration. So here now you can substitute the value of number of moles and concentration in the formula to find volume. Optional, so if the mass is unknown, do not forget to use this triangle whenever is needed. Okay. Step number 3, do not forget the units at the end of your answer. If your answer is too long, round it off to 3 sig fig. Alright, so please read your notes. Please take note which formula is needed and when to use the formula. Okay, it's not only one formula you should use. Sometimes it may be 2 formula or even 3, as long as you know how to do it. Alright, that's all for today. Thank you for watching. I shall see you next lesson.